In today's lesson, we're going to try something a little bit different. We're going to use some technology that we have available to us to examine how graphs can change when you change the numbers in the equations. So the thing we're going to use today is called Desmos. Okay, so you can get on your computer, just type in desmos.com and go to the calculator. Or there's an app you can actually download for a phone or an iPad or something like that. It looks exactly the same. It's going to have this little, I don't know if you can see it, but the icon at the top up here. This thing up there. It does the same thing. So it allows us to graph things pretty easily. If you do go to the website, it looks like this. Just click on Start Graphing, and we'll have our graph. Now, the nice thing with this is it's a touch screen, as is the app on your phone. So you can move things around and analyze things and look at graphs. All our graphs are sort of in the top right corner, we call it the top right quadrant. So I'm going to drag the graph down so I can only see things above 0, basically. So what do we want to do with this? Well, we're going to start off by graphing some things. So I want to graph these equations just the way they look. Y equals 3 plus 2x, and y equals 1 plus 2x. So we'll go to Desmos. Let's tap this first block up here. Okay, and on mine, I have to bring up the keyboard. And we can type in just the way it looks. Y equals 3x. Oh, sorry, 3 plus 2x. Backspace. 3 plus 2 with an x. And there's our graph. Okay. It should sort of be like normal, right? We start at 3 as my y, my initial value right there. And I can sort of see how it's going up to the right. Okay. If you go over to the right, you can type in another equation. So this time it's y equals, and this time we wanted 1 plus 2x. 1 plus 2x. And we get the other equation. Again, has a starting value at 1, our initial value. If you touch things, the dots on the graph, you can get those important points. And we want to answer some questions. So what are the questions? What's the same with the graphs? Well, looking at them, I notice they have the same steepness is a word we've talked about. Okay, so I can write that in here, same steepness. What's different about them? Well, let's take a look at where they start. And they start in different spots. And as we've talked about, we only really care about this spot right here, right? And this spot right here. So I'd say these have different starting points. Okay. Talking about words we've examined before, what's different in the equations, or rate or the initial value? Well, if you take a look at them, here's my initial value and here's my rate. My initial value and here's my rate. Well, they're different initial values, which should make sense in terms of what we're looking at. If they have the same rate, shouldn't they be the same steepness? That hopefully makes sense. And if they have different initial values, well, they should start in different spots. And kind of our objective today is to analyze graphs on how they're the same and how they're different, but also by looking at their equations and figuring out some patterns here. All right, let's try the next one. So go back to our graphs. I'm going to get rid of my clicking on the X. I'll type in some new equations. Y equals. Let's see what happens this time. Our objective down the road is to be able to get rid of the graphing calculator here and just do it in our brains, but it's easier to see if we actually see them, right? Y equals, and y equals 3 plus 2x. 3 plus 2x. Okay, take a look at these ones. What do I notice about them? What's the same, what's different? Well, the same is they definitely start in the same spot. Same starting point. What's different? Well, they're definitely different steepnesses, I think, right? One's much steeper than the green is steeper than the purple. Different, their steepness. Okay, now does it make sense from looking at my equations? Well, they have the same initial value, but they have different rates. Right? It makes sense that they have the same starting point, different steepnesses. In fact, one that has a 5, which is, I'm thinking the green one is much steeper. The bigger the rate, the steeper the line. We've talked about those two things. Okay, let's try some more. So my next pair, 2 plus 3x, y equals 2 plus 3x, and y equals 3 plus 2x. Y equals 3 plus 2x. Oh, what's the same about them? Well, they're not in the same starting place, definitely. Okay, and they definitely don't have the same steepness. So what's the same with them? I would say not really anything. What's different about them? I'd say pretty much everything. Maybe you could say they both go up to the right, but that's about it. Well, does that make sense from looking at our equations? What's different? Our initial value is different. Our rate of change is different. Everything's different. So it makes sense that the graphs are completely separate. Even though they have the same numbers in them, they're actually very different graphs. Okay, so let's play with some of these equations a little bit more. What's our next set look like? 2x plus 4 and 2x minus 1. 2x plus 4, 2x plus 4, okay, and y equals 2x minus 1. Okay, what's the same about them? Well, it looks to me like they have the same steepness, but different starting points. Same steepness, different starting points. Well, let's take a look at our initial values and our rate of change. But what's weird about this one is I put this one out of order. Okay? We don't have to, order doesn't really matter. We just have to pay attention to it. The number in front of x is always our rate. Okay? The number by itself is always our initial value. So it makes sense that they have different starting points because they have different initial values. The number in front of x is both 2. They have the same rate. Okay, so when you're paying attention, when you're looking at an equation, do pay attention to the order of things, because sometimes they're out of order. Okay, we would usually write this as 4 plus 2x and negative 1 plus 2x, but order doesn't really matter. It's what value you have in different spots, not the order you put them in. Okay, let's try one more here. 3x plus 2 and 2 plus 3x. Okay, 3x plus 2, 3x plus 2, and the other one was 2 plus 3x. Okay, what do I notice about them? Well, where is the black one? Well, if I touch the red one and the black one, what do I notice? I notice they're actually right on top of each other. Why is that? What's the same about them? I think everything's the same about them. What's different about them? Nothing. How come? The equations look completely different, or do they? Aren't they just the same numbers in a different order? Isn't that the same as saying 2 plus 3x? Right? So again, these look different, but it's not about order. It's about what value is where, what they mean. Okay, so hopefully we got some ideas about patterns. Okay, we can look for our initial values, we can look at our rate of change, and we should be able to tell by just looking at the equations what's going to be the same, what's going to be different about them. Starting point, steepness, initial value, rate. Okay, here's our real kind of questions we want to get to today. Okay, so without graphing this time, we're going to try and figure out the patterns in these equations. Okay? Which one starts higher and which one is steeper? I know that because of the initial value and the rate of change. So these are nice orders. Here's my initial value. Which one's going to start higher? Well, 4 is bigger than 3, so the second one starts higher. Which one's steeper? Well, let's look at our rates. There's a number in front of x. Which is the bigger number? That's a steeper thing. So number 1 is steeper. And you try the next one. Which of these starts higher? Well, these ones are out of order this time. Here's my initial value. Okay, 4 is bigger than 3, so number 2 starts higher. My rates, which is steeper? Well, the bigger the number, the steeper the line. And the last one, okay, which of these starts higher? Well, my initial value is right here, so 25 is bigger than 20, which is steeper. And 5 is bigger than 2, So 2 is steeper. Okay, just about patterning. Hey, how do we actually apply this? Well, here's our big question. Okay, the best cellular company has a cell phone plan for users. The plan costs $10 a month plus 10 cents a minute. They want to make a table of values. Okay, so I've done this before. Number of minutes cost. Okay, if we go no minutes, it's going to cost us initial value of $10 a month. Okay, they want to go from 0 minutes to 50 minutes. So the easiest thing to do would probably go by 10. It's 10, 20, 30, 40, 50. Okay, how do I figure out 10 minutes? Well, let's think about the equation, right? It's 10 plus 10 cents per minute. So 0.1 for every minute. If I want 10 minutes, I just put in a 10 for my number of minutes. So I'll get 10 plus 1, and that's 11 minutes. How do I get 20 minutes? Well, we do the exact same thing. 10 plus 0.1 times 20. That gets me 10 plus 2, which is 12. Well, there's a pattern here, right? That's our whole idea. We make patterns. There's my table. Let's graph the data. Okay, so they gave us a graph. This has to be number of minutes. This has to be my cost. We can fill in some more numbers here. 20, 30, 40, 50, 60, 90, 100, and 8, 12, 16, 20, 24, 28, and so on and so on. Okay, we gotta graph this data. What do we know for sure? 0 minutes, 10 bucks, right in the middle. A 10 is 11, which is right about there. 20 is 12, we know that one for sure. They start 30 and 13, 40 and 14, 50 and 15, 60 and 16, and so on, right? There's our graph. Okay, why do we do that? Well, part C, write an equation. Well, I kind of already did that. Here's part C. You know, get rid of this stuff. There's C done. D, the company increases its fixed monthly cost to $20, but decreases its cost per minute to 5 cents. How does the graph change? Okay, here's where our thinking is coming in. We're increasing it to fixed cost, but we're decreasing our cost per minute. So that's about initial value and rate of change, right? So if I increase my fixed costs, that means I'm going to start higher. If I decrease my rate, I'm going to get less steep. Okay. That's what we were talking about when we did the equations earlier. Okay. Draw the new graph on the grid. Okay, we can do that. Okay, what do we got to do here? Well, I think it kind of makes sense to let's just add another column to our table here. Cost. Okay, 0 minutes is now going to cost 20 bucks. Okay, I need to find out what happens for 10 minutes. Let's use our equation. Let's make an equation. 20 plus 0.05 x. What happens if I have 10 minutes? 20 plus 50 cents. So it's 20, 50. Kind of already think about knowing the pattern here, right? It went up 50 cents. So it goes up 50 cents. So it goes up 50 cents. 50 cents. Okay, let's make our graph. What do we know? At 0 minutes, we're at 20. Ooh, it's going to be kind of hard to graph the next one. So let's skip that one and do 20 in 21 minutes. And then 40 in 22 minutes. Okay, we can skip over the pattern because we know it's going to make a line anyway. Does that match what we said would happen? Starting higher? Definitely. Less steep? Also true. And the last part of that question, we want an equation, and we already made the equation. Sometimes it's easier to make the equation first, even if they don't ask for it till later. Okay, last one. Anna's going to take some children to the zoo or the museum. The following equations represent the cost of each trip, where x is the total cost and n is the number of children. So I've got two equations, and I've got myself two graphs, graph A and B. We want to know which graph represents the total cost of the zoo. So how can I tell by just looking at the equations and the graphs which one's which, even if there's no numbers on the graph? Well, it comes back to my idea of they start in the same spot, same initial value, but different rates. And the steeper the rate, the bigger the number. Well, graph A is steeper. It's got the bigger number, so A has to be the zoo. Okay, a steeper or bigger rate. Okay, next part. For a promotion, the zoo is offering the following special. All children get in for $2. Can you write the new equation? Well, sure I can. Okay, instead of a cost of $5 per child, now it's going to be $2 per child. And it starts at $8 still. When the axis is given, graph the line that represents this new equation. Well, what's different about it? Not the starting point, still 8. It's a 2 now instead of a 5. So it's way less steep. It's less steep than the 5 or the 4. The 2 would be more like that. So there's my equation. Okay, that's the end of that lesson. I'm going to try some playing with different equations and different graphs and see if we can figure out how to change our situation. Okay, give the sheet a try. If you're stuck, come see me.